Alright, this is 612, conditions for triangle congruence. I'm going to try something a little different this time where I'm going to actually have the worksheet. And in using the worksheet, I can actually, I don't have to spend time drawing terrible drawings, and I can go right through with you, especially if you're doing the worksheet or following along. So let's start with number 11 here. Derek wonders what other types of information can determine that two triangles are congruent. Now, we kind of went over this stuff already, so I do apologize in that maybe I went out of order a little bit. I should have focused more on similarity, but I think this will kind of help you go through it, and I don't have to describe as much anymore. But I will talk about why things end up being true and why other things don't. Now, remember what triangles being congruent means. All it means is that two triangles are the exact same triangle, like the exact same side lengths and angle degrees. So these two, for instance, these look identical enough to me. I figure that these two triangles are congruent. They are identical, like identical twins. So that's all it means. And proofs of that really just mean how little information do you need for proof. You know, just like when you're proving a murder, I mean, do you need to actually be at that moment to actually see it happen, or can you gather a little bit of evidence little by little? Of course, I stack it all up, but my point remains. Okay, so, excuse me. I might have some coughs and water drinks while I do this. Okay, examine pairs of triangles to decide what other types of information force triangles to be congruent. Notice that since no measurements are given in the diagrams, you are considering the general case of each type of pairing. Okay, so what that means is they're not actually numbers, but A, the length of A and the length of A mean the same exact length. Okay, in what ways can you show that triangles are similar? If you remember this, you need to know side, 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 angle, and angle, angle. You could say angle, 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 but angle, angle implies angle, angle, angle. Because, as you know, triangles have three angles in them, and if you find two of them, the third one always is that last measurement. Okay? What must be true in order for triangles to be congruent? Side ratio of 1. We had this in our other notes before. So side ratio of 1. Okay, I'm going to go through this, not necessarily in order, because I want to save HL for last. It's not harder, but maybe it just has a different explanation to it. Okay, we're going to look at these and let's say whether or not they're similar. I have a side here congruent with that side here congruent with that side congruent with that side. I don't think you'd say that. I think you talk about similarity ratio, but in this case, A over A equals 1, B over B equals 1, and C over C equals 1. They all have the same side ratios of 1. So yes, by side, side, side. All of them share the same side ratio. Awesome. Do they have side ratio of 1? Yes, absolutely they do. So in that case, these are actually congruent by side, side, side as well. Now they didn't ask that in this, so I'm not going to actually say that. Sorry. Moving on down, angle, 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 or AA. You can have a third A as well. Again, if you have three angles congruent, you can say AAA. But all you need is two, right? If I say this guy, whoops, let's try that again. If I say this guy is congruent with that guy, and then this guy is congruent with that guy, as noted by the markings, then this guy must be congruent by that guy. Because these two guys add up to something less than 180. If you subtract that from 180, you get whatever's left. Now, there aren't any actual numbers here, no measurements, but we can make that assumption that this guy and this guy are congruent. Whoa. Okay, I think this happened last time. Don't show this message again. I don't know what it is. I think it's the screen capturing thing we're doing here. Anyway, similar, yes, by angle, angle. Okay. Side ratio of 1. Okay. Now, we don't know what these actual side ratios are. For all intents and purposes, this could be 40, and this one going from green to red could be 7. We have no idea. And we can't just assume, right? These aren't drawn to scale. There's no assumption to be made. So we don't know what the side ratio is. Now we know because they're similar, okay? We know because they're similar that they all have the same side ratio. That doesn't mean all of them have the same side ratio of 1. So in this case, no. So there's no proof here to say that these two triangles are congruent. You know, that he killed that guy, right? You cannot convict them. Alright, moving on down. Okay, side-side angle. There's another way to write it if you reverse these letters here, and this is something that does not prove them to be similar or congruent. And here's kind of my defense as to why. Let's say, and I mean, you know, you're going to have to disregard this drawing for a second. Let me actually kind of redraw these again. Well, actually, let's keep this drawing here, and I want to redraw this triangle where I have this angle and this length R, and this is kind of going to go off the screen here, but I'm going to draw a length Q over here. Okay? There's this angle, here's R, here's Q. Q is still the same length, R is still the same length, this angle is still the same, but now this side is different from that one, and this angle is different from that one, and this angle is different from that one. These are not the same triangle, yet I used this angle, then this side in proper sequence, or side-side angle, but these are not the same triangle. Right? That's why this does not work. This does not say that they're similar. Let me put it back in green here. Nor does it say that they are congruent. Now, we did say before, side ratio of 1. Can these, I guess technically not, because this would not have the same side ratio as that. But if anything is congruent, that means it is similar. If it's similar, doesn't necessarily mean it's congruent. It still needs a side ratio of 1. Okay? Moving on over. Sorry, I'm going to skip that again. Going down to ones we've seen before. Angle, angle, side. Now the question here is, can I redraw this triangle using angle, then side, and make it be a different triangle? So can it not appear as the exact same thing like this guy is? Granted, this guy's rotated a little bit. But can I do that? And the answer here is no. There's absolutely no way. Let's see, I can make this angle here. Oh, or can I? This angle here, and this side length. Okay? And you tell me how I can possibly not match this up the exact same way. It has to come at this angle, and it has to meet at this point right here. So it has to go exactly like that one is. There's absolutely no way these cannot be the same side length and not meet at this same angle. So these have to be the same triangle by angle, angle, side. That's why this is proper. I'm talking about congruence, by the way. But going back to similarity, we can prove... well, let's see. Can we prove by angle, angle, side? I suppose. We do know that it's congruent. Therefore, if they are equal, if they are the exact same triangle, they must be also similar. And in this case, you can just say angle, angle, right? This angle is the same, this angle is the same. The fact that this side is the same makes these two triangles equally congruent. Side ratio of 1, well, yeah, because we found this one the same and they're similar. Therefore, they all have that same side ratio of 1. Okay, and the last one here before we get to HL is angle, side angle. Once again, try and redraw this. Use this angle, this side length, and this angle, and try and make it not connect at this exact point with these exact two side lengths. It's impossible. Therefore, there's no other way to reconstruct a triangle using this exact angle, side, and angle. They must be identical. So by angle, side, angle, you can also prove not only do you know that they're similar by angle, angle. By the way, I'm not writing some of these. I should probably start doing that. Well, this one's not true. Okay, I guess I've written them all. By angle, angle, side ratio of 1. Well, if this is m and this is m over m is 1, certainly. And because they all must have a side ratio of 1, I'm sorry, because 1 is a side ratio of 1, the rest also must. So these triangles are also congruent. So I wrote this, whoops, not that one. No. I wrote this yesterday here. Congruence can be determined using side, 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 angle, side, angle, side, angle, side. And I think in the video I actually left out angle, angle, side. I apologize for that. And there's one more which is called HL. Let's go up and do that. HL stands for hypotenuse-leg, and this only refers to right triangles because only right triangles have a hypotenuse. Okay? Now here's what this means, and you need to whip out a little Pythagorean theorem for it as well. Okay? Yeah, this looks like angle, side, side to me. And as we know, angle, side, side isn't a possible thing to use. However, this is one exception because they're right angles. So what we're going to say instead is, if I have this hypotenuse, H, and I have one of the legs of a right triangle, the other leg must be congruent. Let's call it, I don't know, W for width, I guess. I don't know what to call it. Could have called it base. Anyway, the only way that you know this for sure is by Pythagorean theorem. If I have L squared plus, I guess, W squared equals H squared, there's nothing else I can have there other than W, right? I must have that there. This is just Pythagorean theorem talking. So by HL, you can prove triangles congruent. So if I have this length as 5 and 3, and 5 and 3, I don't yet know what this length is. I'm not saying it's 3, but if I do 5 squared minus 3 squared, which is 16, and you take the square root of that, you get 4. Both of these must be 4. And because those are 4, you can then say side, 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 right? But both of these triangles are congruent for that reason. This is by HL. Oh, I'm sorry. Similar. We haven't talked about similarity using HL, but once you figure out what this is with Pythagorean theorem, because it must be that one thing, this would be side, angle, side. Side, angle, side. And side ratio of 1, absolutely, there. Okay, where's that next page? Over here. Okay, this is something that's classwork, but calligraphic pen. Use your triangle congruence conjectures to determine if the following pairs of triangles must be congruent. Mark down facts. Okay, so by facts, you want to say they share a side, alternate interior angles, all those things. You want to do those on the diagram. So we're looking for side, 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 angle, side, angle, side, angle, 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 side. And I'm going to kind of go through these a little more quickly. I'll describe when we have to mark something up. But okay, 2 corresponding triangles. Maybe I want to redraw this other one over here. I'll get 8, 70, and 11. Now remember, don't get tricked by the problems, okay? This side and this angle in between needs to match up with that side, so make sure that always lines up. Otherwise, maybe they don't work. 8 and 8, these sides are congruent. 70 and 70, these angles are congruent. 11, 11, these sides are congruent. By side, angle, side, I can determine, yes, these 2 triangles are congruent. That's as much information as you need to know that. Oh, sorry, let's go on to B. Same thing here. If I take this one and I rotate it over that way, I'm getting this right here, 40, 42, and 31. 31 and 31, 40 and 40, 42 and 42, all congruent. Because of side, 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 I can say that yes, these triangles are congruent. Okay. Here's an example of what I was saying before. Just because we have a 12 here and a 12 here, yeah, those sides are the same length, but they don't correspond to the same sides. As you can see, if I took this and actually, well, here, let's see, this is actually a little different. Not that they're not corresponding to the same sides, this angle isn't the same. If these angles were the same, this guy would be down here, right? That would make these the same thing. However, there's nothing that tells me what the measurement of this angle is. Because I don't know that, I'm looking at an angle, a side following, and then another side. So I can say here that this 16, I'm sorry, not this 16, this 16 and this 12 are the sides to compare because they follow the angle right here after. And this 16 would coordinate with this side right here, whatever that length is. Nothing to indicate that they're congruent here. I can't use side, angle, side, because this is angle, side, side right here. Okay, keep in mind these two lines mark parallel, or these two symbols mark parallel lines. And by parallel lines, let me actually use the line tool for this one. If I have this right here, I can draw myself the lines a little bit bigger. And I'm going to cut these by line transversals. I'll just start with this one first. Okay? If you can imagine that, what we're looking at now is, I'll use red. Here's an angle, and here's an angle, and they must be congruent because of these are alternate interior angles, AIA. So these are congruent. So if I erase those other little things there, take these one by one and get rid of them, you can then see what I meant by that. And if I did the same thing here, parallel lines cut by a line transversal right there, same thing, alternate interior angles. So let's do that one more time. So these two are congruent for the same reason. They are alternate interior angles. Probably something you might want to mark down. And finally, here we have vertical angles. This guy and this guy are congruent because vertical angles, I'll just put VA, are congruent. So now we have three angles, and we could show that this triangle is similar to this one, but are they congruent? Well, here we have 6, and here we have 6. That doesn't automatically mean they're congruent. We want to see what angles they're between. And in this case, if I redrew these triangles, let's say I redraw this one right down here, I use black, and I say boom, 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 and I reoriented this so that the green is now, it rotated this way, so the green is over here, the red is over here, and the blue is over here. It's much easier with letters, isn't it? The blue is over here, and the 6 is between the red and the blue, so the 6 is right here. That 6 matches up with that 6. Because these are congruent, we can now say by angle, side, angle, angle, side, angle, that yes, these two triangles are congruent. So again, that reorientation might be really important for some of you. It sure is for me. I like to get that perception. Okay, 4 more. Let's see how quickly I can blast through these right here. Again, parallel lines, not congruent. Arrows mean parallel. So these are already marked to be congruent. Maybe that'll help you out here. This line cuts through the parallel line, so I can say that their alternate interior angles are congruent. Okay, so by angle, angle, I can then say also, obviously, then these two angles are congruent. It's not drawn to scale. It doesn't look like it, but angle, 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 angle. Okay, so I can say by angle, angle, these are I'm sorry, not congruent. These are similar triangles. Okay, they have all the same angles, but there is nothing that represents their side lengths. I know nothing about the sides, and I cannot just say by angle, angle, angle that these triangles are congruent. Because imagine I have two triangles, this guy and this guy. They share the same angle measurements, but different side lengths. We don't know what they are, so we can't assume. So no, no proof, not congruent. Okay, right here, is this a right angle? We do not know. They do not tell us. Do not make that assumption. But we do know these sides are congruent, that's given. These sides are congruent, that's given. And now they share this same side right here. I want to call it an altitude, but I guess I can't assume that. But I do know that any side is congruent to itself, right? This is called the reflexive property. I can say that a side shares the same length as itself, obviously. If you're 5'9", you're 5'9", right? There's nothing else to it. So the reflexive property says that a side is congruent to itself, and that's only the case because it shares both triangles. So by side, 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 and side, 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 I can then say that yes, these triangles are congruent. But again, it says nothing about right angles here. I can't use side, angle, side, or say this bisects this angle into two congruent angles. Nothing that I know for that. This is the only way you can prove it. Alright, the last two. I have marked up angles, angle, 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 and angle. No sides determined, except this kind of starts to share it a little bit here. Nothing for me to say anything about the sides being congruent or anything else. So I cannot use any other information. I cannot use angles alone to say they're congruent. So I can say they're similar but not congruent. Angle is not enough, so no. Moving on. Last one here. Two angles, congruent. Two sides, way on the opposite ends, congruent. I can say these sides are congruent to one another, reflexive property. Okay. Now, is that enough to prove they're congruent? Do I know anything else about bisecting these angles? No, not necessarily. So, can I say anything about this angle right here, this angle? No. By angle, side, side, that is not appropriate to say that these triangles are congruent. And I gave you a reason before. Because this side, for instance, could have been drawn over here. Oh, well, I'm sorry. I guess not over there. This side could have been drawn over here, and this length would have matched up to it right there. There's nothing to say about those lengths. So you cannot use that to say the triangles are congruent. No, they're not congruent. And that's all for 612. Just make sure that you keep these guys in mind. None of these were HL, by the way. If they have right angles, maybe they can help you out. But use those. If you have any questions, go and ask away.